Hello everyone. So in the previous lecture we have discussed about the liquid crystal display commonly known as LCD. And today we will quickly go through about LCD and we will see a detailed discussion about LED. So an LCD is a flat panel display technology widely used in televisions, laptops, computer monitors, calculators and smartphones. Unlike a CRT display, an LCD is thin, lightweight and consumes less power. One important point to remember is that an LCD doesn't produce light by itself. Instead, it controls the light from a backlight using liquid crystal molecules. When an electrical voltage is applied, the liquid crystal molecules change their orientation, allowing different amounts of lights to pass through each pixel. This process creates images, text, and videos with good clarity and color quality. The major advantages of LCDs are low power consumption, compact size, excellent contrast, lightweight construction, and low heat generation. However, LCDs also have some limitations. They require a backlight, have a limited view angle, slower response time compared to newer displays, and their performance may be affected at extreme temperatures. Because of these features, LCDs became one of the most popular technologies and are still widely used in many electronic devices today. Now, let us move on to the another display technology, that is light emitting diode or LED. An LED is a semiconductor device that converts electrical energy directly into light energy. It is basically a PN junction diode that emits light when it is operated in the forward biased condition. The working of an LED is based on the principle of electroluminescence. When the forward bias is applied, electrons from N type region and holes from P type region move towards the junction. At the junction, they recombine and release energy in the form of photons, which appear as a visible light. The color of the emitted light depends on the semiconductor material used and its band gap energy. Different materials produce different colors such as red, green, blue, yellow, and white. Compared to conventional light sources, LEDs consume very little power, have a very long operating life, generates less heat, and provides high brightness. Due to these advantages, LEDs are widely used in television, smartphones, traffic signals, digital displays, automotive lighting, decorative lighting, and electronic indicators. So, this is the working principle slide which we have discussed earlier. So, these are the different types of LED. Surface mounted LEDs are SMD, through hole mounted LEDs, high brightness LEDs, chip on board LEDs, that is COB, RGB LED, graphene LEDs, 7 segment LEDs, and alphanumeric LEDs. So we can see the different types of LEDs picture representation in this slide. So now if we go in detail about the LED construction, an LED is made of semiconductor materials, that is P and N type regions, called as a PN junction diode. So this semiconductor chip is mounted on a reflective cup which directs the emitted light outward and improves brightness. The anode is positive terminal connected to P type material, and while cathode is negative terminal connected to the N type material. Fine connecting wires provide the electrical connection to the semiconductor chip. The entire assembly is enclosed in a transparent epoxy resin thin lens. This lens not only protects the semiconductor chip from dust, moisture, and but also focuses and directs the emitted light. The shape and color of the epoxy lens depend on the application of the color of light LED produced. This simple construction makes LED compact, reliable, and high efficiency. So we discussed about band gap, working principle, and types of LED, and the different picture representation, advantages and disadvantages. You can refer to this website for more detail about the LED working principle. So that's all about LED. So this slide shows the graphics display, which contains system bus, I/O devices, display processor, system M by M, CPU, display processor, frame buffer, video controller, and monitor. So this shows how a display is projected from I/O. So it looks like a basic microprocessor system. So that's all about LED and LCD. So in the next class, we will discuss about the optical storage devices, that is compact disc, DVD, Blu-ray, like devices. So far, we have discussed about the CRT monitors and LCD and LED displays, which is more widely used in today's applications. So it has many, even though it has many advantages and disadvantages, both LED and LCDs are mostly used in many applications. So if you take, even though the LED has less uh, uh, efficiency due to its long lifespan of LEDs, it is most widely used in lighting technology today. And one limitation is these LEDs require current limiting circuits or drivers because they cannot directly connected to power supply. So this is the only limitation with respect to LED. And one of the major advantages is low power consumption and long battery life. So using LED, we can uh, operate about 50,000 hours, which reduces the maintenance and replacement costs. And also it generates very little heat, making them safer and more energy efficient. So and also it is very compact, so they do not contain many fragile elements. So these features make LED environmental friendly. So thank you for watching this lecture. We'll discuss about the optical devices in the next lecture.